Hi, I'd like to solve a few more exponential equations with you. I'm going to assume you've already watched my first solving exponential equations video. So the directions for the problems in this video will be these: solve, express irrational solutions in exact form first, then express the solutions as decimal approximations rounded to 3 decimal places. And the 3 equations that I have written here are the 3 that we're going to solve in this video. So let's start with the first one. So it is 8 to the 0.23x minus 25 equals 14. Notice I didn't write the directions because I wanted to have the whole space for our work. So let's begin. We'll start by adding 25 to both sides so we can get that exponential all by itself on the left-hand side. So when we do that, we would have 8 to the 0.23x equals 39. Now I'm going to take the log of both sides, and because I don't see a base e and I don't see a base 10, I don't really have a preference about whether I use our common log or our natural log. I can use, that means our base 10 or our base e logarithm, and it doesn't matter. So for this problem, I'll just use base 10. So I'm going to take the log of both sides. And by doing that, we now can use our property that says we can bring our exponent in front. So we have 0.23x times the log of 8 equals the log of 39. Now on this one, I'm going to divide by 0.23 and by the log of 8 at the same time. For some reason, people want to do that on 2 different steps. It makes it nice if I do it at the same time. 0.23 and the log of 8. And see, they would both cancel here, and I would be left with x. So on the right-hand side, I have 0.23 times the log of 8 as well. So the exact value, remember that's what the directions say, express the exact solution first. That means don't touch your calculator until you get to the very end. So I have the log of 39 divided by 0.23 times the log of 8. And now we're going to punch that into our calculator and we'll get our decimal approximation. I do want to make sure that you are aware of one thing. A common mistake that happens is that the L in log sometimes gets written really close to the number here. So people punch in a 0.231. Happens all the time. In fact, I have in the past written my expression this way so that I wouldn't have that problem. 0.23 and then the log of 8 this way, so it doesn't look like a 1. But it doesn't matter, just make sure you take care. So now I'm going to punch this into the calculator. I get this value. The directions asked us to present the answer to 3 decimal places, so I'm going to go right to here. So I have x is approximately equal to 7.660. If you're asked for 3 decimal places, don't exclude that 0 there at the end. Let me talk briefly about entering this in on your calculator. There are a variety of calculators out there, so the way that you would enter it can be different on different calculators. But do make sure that you notice the log of 39 is in the numerator, and both the 23/100ths and the log of 8 are in the denominator, and a product in between. So you could have that look like this. If you're punching it into a calculator, it could be the log of 39 divided by, and put in parentheses, the 0.23 times the log of 8. As another option, if you want to avoid parentheses, you can put in the log of 39 divided by 0.23 divided by the log of 8, and that will also give you the same result. And of course, on many of your calculators, you can just punch it in, and you'll be able to see that it will look just like this. In any case, practice and make sure that you get the correct answer. Here's our next example. To begin, I hope you recognize that we could multiply both sides by this denominator. So let's do that. I'll multiply both sides by 1 plus 7e to the negative 0.06x. Same thing over here. And I will cancel on the left-hand side. So now I have 1,000 equals 750 times 1 plus 7e to the negative 0.06x. Don't let it bother you that I didn't put the leading zero here, and here I did. Of course, those are equivalent. Let's continue. There's a choice here. You can either distribute the 750, that works very well, or you can divide both sides by 750. I think that's what I'm going to do. I'm going to divide by 750. But either way is totally fine. So when I divide by 750, my next line will look like this. 4/3 equals 1 plus 7e to the negative 0.06x. Again, I want to isolate the exponential, so I'm going to subtract 1 from both sides. And we know 1 is 3/3, so 4/3 minus 3/3 is 1/3. So I have 1/3 equals 7e to the negative 0.06x. Now I can divide both sides by 7 to isolate that exponential, but I'm going to think of that as multiplying by 1/7, right? I know I could write it this way, but dividing by 7 is equivalent to multiplying by 1/7. So I'm just going to erase this and multiply by 1/7. So now I have 1 over 21 equals e to the negative 0.06x. And you can see I haven't been consistent about whether I have the leading 0 before the decimal point and whether I don't. Let's continue. We're going to take the log of both sides now. Since I have a base of e, I want to use my natural log. So I'm going to take the natural log of both sides. So ln of 1 over 21 on the left and ln of e to the negative 0.06x on the right. On the right-hand side, then, I'll have negative 0.06x times the natural log of e. And on the left-hand side, the natural log of 1 over 21. The natural log of e, we know, is actually equal to 1 in the same way that we know the log of 7 base 7 equals 1 and the log of 10 base 10 equals 1. So I can rewrite the equation as the natural log of 1 over 21 equals negative 0.06x. And last, I'm going to divide both sides by negative 0.06. And I have the equation in exact form. But let me mention this. This is a great example of a problem that people see, and then they look in the back of the book or the answers that they know for a particular problem, and they see it doesn't match, and they try to go find a mistake, and they'll spend a lot of time doing that. But let me show you how the answer could look different. We have the natural log of 1 over 21. We know that equals the natural log of 1 minus the natural log of 21. The log of 1, regardless of the base, is equal to 0. And we have the natural log of 1 over 21 equals negative natural log of 21. That's a big deal. We should know that. And let me mention another way that you can see that. We know that the natural log of 1 over 21 is equal to the natural log of 21 to the negative 1 power because we know about exponents. And now we can use our property of exponents that says, hey, this exponent right here can come in front as the coefficient. So I would have the negative natural log of 21 that way as well. So let's make a substitution for the natural log of 21. And I'm going to slide this up a little bit so I have some space. And I have x equals negative ln of 21 divided by negative 0.06. And I have x equals the natural log of 21 divided by 0.06. And I would say this is okay as an answer, and this is better. Let's make our final step, getting our decimal, so we can punch that in on our calculators. And we get x is approximately equal to 50.742. Remember, the directions said to give our decimal approximation to 3 decimal places. So let me shrink this down just a little bit so you can see the entire problem. Again, here is our exact solution, here, and here's our decimal approximation. And here's our third and final problem. When we get to the end of this one, I want you to see how many different ways you can present the answer. But let's get started. We know we cannot multiply the 20 by the 11, right? That would break our order of operations. We can't multiply before we would take care of an exponent. But we do want to get rid of this 20, so I'm going to divide both sides by 20. And we'll get that exponential alone. So we have 11 to the x plus 1 equals 1/4. Now we're going to take the log of both sides. I don't see a base 10 or a base e, so it doesn't matter whether I use the common log or the natural log. I think on the first problem I used the common log, so I'm going to use the natural log this time. So remember that doesn't matter at all. But it is important that you use the same logarithm on both sides, the same base on both sides. Now I have this exponent. It's going to come in front. So I have x plus 1. Whoops, let me have x plus 1 times ln of 11 equals ln of 1/4. I have a choice now. I can either distribute the natural log of 11 to both of these terms, or I can divide by natural log of 11. For this problem, either one works fine. So we divide by ln of 11, ln of, whoops, let me fix this. We have ln of 11. So it cancels on the left, and we have x plus 1 equals the natural log of 1/4 divided by the natural log of 11. And let's subtract 1. So we have x equals the natural log of 1/4 divided by the natural log of 11 minus 1. And for clarity, we could put parentheses around that 1/4. Now, I mentioned on this problem I wanted to show you how many different ways this answer could look. This is one way, but let's find another. We could get a common denominator with these two expressions and put it together as a single fraction, and sometimes that's desirable. So I'm going to come up here, and I'm going to start listing the different ways that the answer could look. So we have ln of 1/4 divided by ln of 11 minus 1. When we get the common denominator, you know you would be multiplying by natural log of 11 over natural log of 11. So our answer would look like this: ln of 1/4 minus ln of 11 divided by ln of 11. Again, we just get a common denominator here, and we rewrite our fraction this way. Now we can do what we did in the previous problem. We have this natural log of 1/4. In the same way, I think we had the natural log of 1 over 21 in the last problem. And you can do the work and confirm that the natural log of 1/4 equals negative natural log of 4. So let's put that in instead. Negative natural log of 4 minus natural log of 11 all over natural log of 11. Let me do something else. See how there's a common factor of -1 here? We could factor that out and put it in front. Let's do it. Negative natural log of 4 plus natural log of 11 divided by the natural log of 11. And let me show you one more way in which these could be written. Let me erase this down here so we have space. We know that our first property of logarithms says the sum of two logs is the log of a product. That means we can take the log of 4 plus the log of 11 and rewrite that as the log of 44. And of course, I mean natural log. Natural log of 44 over the natural log of 11, and we still bring that negative down. So you can see there are many different ways that this answer could look in its exact state. Do you see which one probably looks the best? I don't want to belabor this too much, but I see people spin their wheels a lot trying to figure out what went wrong up here when really they should be working over here to make their answer look different if they're trying to match an answer that's been presented to them. So let's punch in the value for this problem. We didn't answer the approximate value for the solution. And of course, you can choose whichever one you want to punch into your calculator. And I get negative 1.578. I hope you'll go solve some exponential equations.